Hello everyone. Let's look at the following problem. We see that we have graph of velocity with respect to time t, and the slope of both functions that represent velocity is constant. And as we saw before, the slope is actually acceleration. So we can say that A and B they both have constant velocity, not the same, but just constant. Okay, so let's see. Also, we're given that at time of t 0 seconds, both objects at the same position of 0 meters. Okay, first question: when and where those two objects will pass each other? The second question: what is the velocity of object A and B when they actually pass each other? Sometimes it confusing people. They think, or students, they think that at this point, okay, they actually have the same position. No, it's not. To be sure, we need to calculate and find actually the position when those two objects actually will pass each other. Okay, to answer the first question, we need to find or to calculate or find function that represents a position for object A and object B. Now, which formula I'm going to use? I'm going to use this formula. Okay. Now, okay, I know that the position at time of 0 seconds of object A. Also, when I look at the graph of velocity, I also can say that I know the initial velocity, which is 0 meters per second. However, I do not know still the acceleration of first object A. So we're going to use this formula, okay, or definition of velocity, constant velocity, which is delta V divided by delta T. Okay, do we have 2 points or coordinates? Yes, we do. This is the second coordinate and this is the first coordinate. When we look at delta V, it's actually 6 minus 0. And when we look at delta T, it is 10 minus 0. Let's see the calculation. This is the calculation. And finally, the acceleration of object A is 6 divided by 10 meters per second square. And finally, we can substitute all those parameters with known values. Okay, again, at 0 second, okay, the initial velocity is 0 and initial position and 0, also 0. Finally, okay, we get this expression for function of position of object A. Very simple parabola. Happy parabola because the coefficient, okay, 3 divided by 10 of t squared is positive. That's why this parabola is happy or smiling. Okay, also for the object B, I'm going to use the same formula. Now also here, I also need to find the acceleration of object B. Again, let's check if we have two coordinates. Of course we do, second and first. If we talk about delta V, it's 6 minus 9 divided by 10 minus 0. Let's see. Again, 6 minus 10 divided by 10 minus 0. Okay, and finally we have minus 3 divided by 10 meters per second square. And again, we're going to substitute all those parameters of this formula with known values, which is we can see here, okay? And finally we get this expression okay, of position of object B. Actually, we can also say that this parabola would be unhappy because the coefficient of t squared is negative. Now, if we want to calculate the position and time when those two objects actually pass each other, it's a common sense to say that we need to say that the position is the same of A and B. So we're going to substitute the expression of xa of t with this function that we found before. The same goes for the object B. Okay, from this step is actually just mathematical steps. You can take this term and move it to the left. The sign, of course, will change from minus to plus. Now, what we can do, we can actually we can factor out the common factor of t squared, okay, and we can add this value with this value, which will give us this value, 9 divided by 20. Okay, let's move this term to the left, and again we can factor out 9 times t. In the brackets we will have t divided by 20 minus 1. Okay, this part will give us very trivial solution, which of course we know that it was actually given in this question that at time of 0 second they have the same position, which is x of a, x0b equals 0 meters. We know that, but we need to find when they actually pass again. So this part, the second part, will give us the second time. I mean, this part gives us this result, that at time of 20 seconds, they have the same position. Now, I also want to find where easiest way to use this expression, okay? We could also use this, but this one is easier, much easier. So we're going to substitute t squared by 20 seconds, or 20 squared, okay, which finally will give us the position. This is when, and this is where, okay, 120 meters. Okay, this one was the first question. Second question, we need to find what is the velocity of each object. Now, before that, we need to find what actually is the function of the velocity for each object. I'm going to use this formula. Okay, we know that at time of 0 second, the initial velocity of object A is 0 meters per second. We also calculated the constant acceleration, okay, which is 6 divided by 10 meters per second squared. And finally, we get this expression for velocity of object A. As you can see, it's actually a linear function. Now, the same goes, the same steps goes for the B, object B. Again, we're going to use the same formula. And again, we're going to use the same initial time, 0 second, which we know it's 9 meters per second. If you don't remember, you can always come back to the graph. And you can see the initial velocity of the second object B is 9 meters per second. Here. Velocity, acceleration we already calculated. And finally, we get this expression for velocity, VB of t. Now, we're gonna use time of 20 seconds, okay, and substitute in both functions that represents the velocity of two objects. Okay, now VA, the velocity of object A, equals to 6 divided by 10 times t, which is 20 seconds. Finally, we get this value, 12 meters per second. Okay, let's see what value we will get when we will talk about the second object B. Okay, we get 9 minus 3 divided by 10, okay, times 20, which is t. Okay, finally we have the value of 3 meters per second. The second question we can ask, can you draw the graph of xa of t and xb of t? Okay, now the blue one is object A, and if we remember, xa of t equals to where is A? Yeah, this one, which is happy parabola. Initial velocity of A is 0, and if you remember, the tangent of parabola at time of t0, it's actually instantaneous velocity of object A, which is 0 meters per second. This is one tangent VA when t equals 0 seconds equals 0 meters per second. And if we look at time of 20 seconds, we found that the velocity of object A is 12 meters per second. It's actually the tangent, okay, of function of xa of t at time of 20 seconds, or you can say instantaneous slope at this point is actually the instantaneous velocity of object A. Now what about B? We know that initial velocity of object B was 9 meters per second. So it's actually the slope or instantaneous slope or tangent, okay, which is V0B equals 9 meters per second. And this is unhappy parabola, as I said before, but we found that when t equals 20 seconds, when the object A and B pass each other and the position is 120 meters, the velocity of object B is actually 3 meters per second, which the slope is less than the slope of object A. And again, the slope is actually tangent of this parabola at t equals 20 seconds, or its instantaneous velocity at the same time of 20 meters and 20 seconds. I'm sorry. As you can see, okay, when we look at this coordinate, the position is the same, however, velocity is not. So I think I'm gonna stop at this point. In the next problems, also gonna calculate maybe, no, not maybe, it's for sure. I just don't know if it will be at the next problem or not. I'm talking about average velocity. But it's enough for this problem. I will see you in the next problems. Bye bye.